Hey guys, welcome back to my YouTube channel. Today we're going to be looking at a stoichiometry type problem on ALEKS. So it reads, ancient Romans built, okay, this is all nonsense, don't worry about that. This is the actually important part. Write a balanced chemical equation including physical state symbols for the decomposition of solid calcium carbonate into solid calcium oxide and gaseous carbon dioxide. So I guess we'll just write it out. So it gives us the first part. Hold on, give me a sec. So we're just gonna write it out. And then decomposition, so it just breaks down into CaO. Actually, we gotta include the physical state. S plus CO2, this is the gas. So whenever you're balancing out the chemical equation, what you gotta look for is to make sure that everything's on like the left side is equal to the amount of that same thing on the right side. As you can see, it already is, because you get one calcium, one here, one carbon here, and then 3 here, but there's 1 here and then 2 here, so that's 3. So you don't got to do anything there. So that's the first part. The second part is, I'm not going to read it because you can read it yourself. But the idea is that in order to find the mass in grams of this, you have to convert what we're given in liters of this using the ratio from one to the other. Obviously the ratio is 1 to 1. As you can see here, if there's like another number like 2, 3, or another number like 2, 3 here, you'd have to multiply accordingly. But we don't have to. So now to do this part though, we got to use the ideal gas law equation thing. And to do that, let's just write it out. So it's PV equals nRT. And what we want is moles, because once we have moles, we can use that to find moles of carbon dioxide. It's going to be the same number of moles for this, right? So we're going to like switch around the equation to n, which is moles. Make that bigger so you can see it. N, lowercase n for moles, is equal to PV over RT. Right, so let's just calculate that on here. The pressure is given as 1, so I'm not going to include that. The volume though, it's in liters, that's what we want. So we're going to put 57 over the gas constant, which is 08206 times, what is the temperature? 390. So 390 is in Celsius, so we want to convert that to Kelvin. 273.15, but I guess we don't use that. And then yeah, so you get this number, which again, you got that number from manipulating the ideal gas law equation thing. And so you get this. This is the number of moles of carbon dioxide, and since the ratio is 1 to 1, this is also the number of moles for calcium carbonate. So now that you have that, you have to convert, and again, what it's wanting is it wants the mass of it, like in grams, and we already know the moles of it, so we have to convert this mole to grams, right? So to do this, we got to figure out what the molar mass is. The molar mass, obviously, you can get by just like looking at this, Ca calcium, C carbon, and 3 oxygen, and then just like going to each of these and adding up the atomic mass number for all 3, or for all, what is this, 5 of them, and you should get this number, 100,069. So what we're going to do is, if you really want to like illustrate what's actually happening, is we can write it like this. We can write 1 mole of calcium carbonate is equal to, let's just say 100 grams. Where'd it go? Here it is. 100 gram. And then you gotta imagine that this is being multiplied by, what do we have? We were given moles. So this is actually upside down, so it's gonna be 100 grams over 1 mole times this mole, right? So that they're like crossing each other out like diagonally and whatnot. So what you can do is you can just, since we know that we're gonna multiply 100 grams, or actually 100 this, but we're just gonna take this and we're going to multiply. We're gonna multiply it by 100, and yeah, that's it. And then for the 3 significant digits thing, obviously it's gonna be 105, or I guess we could represent that with scientific notation, but I don't think we would we? And yeah, that's it.